Right, today we are going to go over natural logarithms from Module 8, Lesson 4, and Reveal Algebra 2. If you go back to the exponential unit, we had this thing called a natural base. A natural base was e, and we didn't really do a ton with it except for kind of go over that it exists, that is an irrational number like pi, and that has an approximate value that is a non-repeating, non-terminating decimal. And so what we really need to understand here is that a natural logarithm, right, is abbreviated as ln of x. And so we're going to use that ln button a ton, right, because it's a natural logarithm. Right? And so natural logarithm is ln. It's on your calculator as a key right underneath log or right beside log in most cases. Right? And a natural logarithm will cancel out the natural base e. And so if I have e to the power of x, and then I do ln of e to the x, the ln of e would cancel out, and so I would just have x. So they are inverses of each other. Right? They are inverses of each other. So just like when we had before, we had log undid an exponential, right? Natural logarithm undoes the natural base exponential. And so the book does a nice job here of explaining that e to the power of x equals 14. Now remember, if you go back, remember we first started this unit, we said, hey, we know something like 5 squared equals 25. And so then we learned to write that in log form, log base 5 of 25 equals 2. And so you could write the same thing in either exponential or logarithmic form. And so that's what we're going to do first here, is switch between forms. And so if you have e to the power of x equals 14, that's really saying log base e of 14 equals x. Well, log base e is just ln. Right? Or if they said, let's look at some other examples here. If we said e to the power of x equals 72, then it would just be ln 72 equals x. Or if they said e to the power of 4 equals x, then it would be ln x equals 4. And so all they want you to do is to switch from exponential form to logarithmic form. And then we'll do some the other way. And so right now think, what is this one? What would this one be in logarithmic form? Right? Hopefully you said ln x equals 7. Right? Again, we're just going now for the other way, from logarithmic form to exponential form. So this is log base e. So it's just saying e to the power of x equals 9. And so if I had, let's look at another example. If I have ln of 7 equals x, then I would have e to the power of x equals 7. If I have ln of 3.2 equals 4x, then I would have e to the power of 4x equals 3.2. Or if I had ln of x equals 12, the e to the power of 12 equals x. Okay. And so again, we're not solving anything here, we're just writing them from one form to the other. And so this time we're switching from logarithmic form to exponential form. And so look at the next example. What is it in exponential form? This was confusing in class because some people don't understand that means equivalent. That's really just saying, hey, I rounded. Remember, rounding is bad the more advanced you get in math. And so we warn people that we rounded. And so this would be e to the power of 1.7347 equals x. And actually, I should probably have used that same, hey, I rounded symbol, that equivalent or about symbol. So now I'm using all of my old rules. Remember the old properties we already have learned. We have the power property. All right, we have the product property. And we have the quotient property. Right. Product property, remember, real quick review. Power property. Power. All right, property was if it was like, 5 to the power of x, then I could put a log in front, and that log allowed me to write it as x in front of log 5. So I can pull the exponent off. So that's the power property. Also, if it's written like this, I could put the exponent on, right? That's power property both ways. And then I'll just show one of them. Remember, back when we did exponentials, x squared times x to the third, not x to the fifth. So when we're doing exponentials, multiply meant add. And so now we have the reverse. Adding means multiply. So if we have like log 4 plus log 2, that would just multiply and become log 8. Right. Quotient property is the subtraction goes with division. Right. Let's look at the example. Those are all old rules. Hopefully that was a quick review for you. If not, you can go back and look at the older note videos. And so I always need to do power property first. Anywhere and everywhere there's a power property, do that first. All right. Please excuse my dear Aunt Sally. Order of operations, always have to take care of exponents first. All right, so always have to do power property first. Well, this one, there is only the one place, and so ln of 8 to the 1/3. All right, but I don't do it first just because it was the first from left to right. I do it first because I do power property first. No matter how many times it happens, I do all the power properties first. Now I do product property and quotient property from left to right. But before I do that, I got this 1/3 here, and a lot of you might be like, oh man. Remember, something to the 1/3 power is really saying to do cube root of 8. And the cube root of 8 is 2. And so it's just really saying ln 2. So even the ones in the homework, they work out pretty nice and neat. Right? So we're not trying to trick you. We're just trying to practice these rules. So we did the power property review. So now we're going to do the first two. There's a minus, and so I do the quotient property. So it becomes ln of 2 divided by 3 plus ln of 9. And then I'm going to do product property here. And I multiply, and so let me just, on a sidebar here, show 2/3 times 9 equals 18/3, which equals 6. And so this is just ln 6 over here. First thing I have to do is which of these properties, power, product, quotient, which one do I have to look for first when I'm combining things to make a single logarithm? Which one do I have to look for first? Hopefully you said power property. There's two instances of that here. There is the 1/4 in front, which goes now as an exponent. And then there's the 2 in front, which now goes as an exponent. And so 16 to the 1/4 power is just the 4th root of 16, which is 2. And 2 squared is just 4. And so really I have ln 2 plus ln 10 minus ln 4. Well, from left to right, I do adding first. Adding ends up being multiplying. Product property, ln 20 minus ln 4. Subtraction ends up being dividing, quotient property. So I get my final answer here, natural log of 5. Again, here, this is just saying you need to understand that the e and the ln are inverses of each other. They cancel out. So if I have e to the power of ln, those cancel out. I just have x. I have ln to base e, ln of base e, I should say. Then those cancel out. I just would have x. Okay? So I use these to cancel each other out. So that's my use. And so let's just solve a math problem. I'm trying to get x by itself. Got to do a lot of steps to get there. First thing I do is move this 8. Do the opposite of plus 8. Do minus 8 to both sides. So I have negative 2e to the x plus 3 power equals negative 22. And that's negative 2 times, so I do the opposite, I divide by negative 2. And so it's e to the power of x plus 3 equals 11. Now, I don't want x to be an exponent. Get down, x. How do I get it down? I log both sides. And so because it's e, it's a natural log. And so really, if I really show all my work here, I would have x plus 3 in front now of ln e equals ln 11. And hopefully you remember ln e. ln e cancels out. So really, I just have x plus 3 equals ln 11. I minus 3, I get x equals, I minus 3 to both sides, ln 11 minus 3. So take a calculator. Take a calculator. Do the natural log of 11 minus 3. And I get on my calculator screen that x equals, it said 10 thousandths, so that's 4 decimal places. Oops, it's a negative though. So I should start with negative. Negative 0.6021. You try. What's the first step? Nothing to add or subtract this time. What's the first step? How do I get rid of that 4? Right now it's 4 times. How do I get rid of the 4? Hopefully you said you divide both sides by 4. So you have e to the negative 2x power equals 3.75. To get rid of the ln, or to get rid of the e, I have to ln or log both sides. And so now on the left side, the ln and e cancel out. I just have negative 2x equals the natural log of 3.75. So I divide by negative 2. I get x equals. I take my calculator. I want to do what is the natural log of 3.75. And then I divide it by negative 2. And I get negative 0.6609. I had 8 at the end, but it rounded up, so we just put a 9 there. And that is the assignment in class. I wish you the best of luck. Hopefully this